So let's start the class. In the last class, we did talking about N-slit diffraction pattern. Now we are saying that there are actually large number of slits, and those slits could be, as I said before, they can be 4 or 40 or 4,000. So you have a large number of slits here. And we are again assuming that the size of the slits is same. That means the width of every single of these slits is same. And since we earlier took the width to be B, so we'll stick with the same notations. And the width of our slits we are going to say is B here. And there will be, I should draw a dotted line here. And then let's say that there are a lot many slits, and this is the last slit here. This is our nth slit. So let's say this is your first slit, this is your second slit, this is your third slit, and then there are in between a large number of slits, and this is your nth slit. Let me write it capital N. You have again a convex lens to focus the light on the screen. And let's say this point P is the point where you are trying to look at the intensity. You want to find out whether at this point P, you should be expecting a maxima or you should be expecting a minima at that point. So as we did in the case of single slit or double slit, each one of these slits you can again divide into small n number of points. Let's say this is your first slit, this is your second slit. And since all the slits are of the same size, so the number of points into which you are going to divide these slits, they are also going to be the same number of points. Let's say this is then C1, and then this is Cn, and this is your nth slit. So let's call this as P1. I have already used P here. So let's call this as S1, and then this is Sn. Last point here. So wavelets which are going to arise from the first slit, they will be reaching point P earliest because they will be traveling the minimum distance as compared to the other slits here. Single slit we have already dealt with. What would happen to the different points from the single slit? Now if you talk about the second slit here, in the second slits, the wavelet that are going to start from the second slit, they are going to travel certain amount of distance extra as compared to slit 1. How do we calculate that distance? We have done that in sufficient number of times now that we know that we simply have to draw a perpendicular from here to here. If you draw a perpendicular from here to here, and if theta is your angle of diffraction, that means all the wavelets are going to be diffracted by an angle theta, irrespective of the slit from which they are originating. All of them will be diffracted by the same angle. So if there are n number of points here, the wavelets which are starting from n, for example here, for those points, there is a point Bn. Corresponding to An, there is a point Bn here, and you can draw a perpendicular from An to Bn, and the path difference would be same as is the path difference between A1 and B1. Let's call this perpendicular point to be B1 prime. You can easily do the calculation. We said that if this opaque thickness is A, then the distance from the top of this slit, let me change the color now. The distance from top of this slit to the top of second slit is A plus B, and that we defined as D. And this is equal to basically A1 B1, and this is also equal to B1 C1, and this is also going to be equal to C1 D1, and so on. Between any two slits, if you measure the distance from top of one slit to the top of the second slit, the distances are going to be the same in each one of the cases here. This distance here, if this angle is theta, this angle is 90 minus theta, this is a right angle triangle, this angle is again theta. That means this distance is going to be d sine theta. So all the wavelets that are going to start from the second slit, they have to travel d sine theta distance extra as compared to the wavelets which are starting from slit 1. What you can do is that you can keep on doing that. You can draw a perpendicular on the next slit also for the wavelets which are starting from the third slit. There, the distance here, if this distance is D and then B1 to C1 is also D. This would basically imply that A1 to C1 is 2 times D. Yahan se from this point to this point, your distance is going to be 2D. So again, in this right angle triangle here, and now your right angle triangle would be this triangle. If you are saying that this distance from here to here is 2 times D, then this distance is going to be 2D sine theta. This was your slit number 1. If you talk about the slit number 2, the wavelets which are starting from the second slit, the extra distance they are traveling as compared to slit 1 is D sine theta. If you go to the next slit, for example, to the third slit, we have done for the third slit. For the third slit, the distance is 2D sine theta. You can keep on doing that. For the fourth slit, you can figure out a pattern from here itself. For the second slit, it's 1D. For third, it's 2D. For the fourth slit, it's going to be 3D sine theta. And so on. So if you talk about nth slit, which is the last slit here, and as I said before, this nth slit could be your 4th slit, 40th slit, or 4000th slit. This is going to be n minus 1 d sine theta. This much extra distance is going to be traveled by the wavelets which are starting from this nth slit as compared to wavelets which are going to start from the first slit. From the single slit diffraction pattern, we know what would be the resultant disturbances. If I talk about the first slit, we know what would be the disturbances that would be reaching at point P. We have already derived this expression. If you do not remember, go back to the single slit diffraction pattern, and from there you will see that this was our resultant disturbances due to single slit if there would have been just one slit in the picture. We did talk about two slit also, right? While talking about the two slit, I said that for the second slit, your wavelets are going to travel this much extra distance. There is a relationship between path length and the phase difference, right? We always say that your lambda, if you talk about the path difference, your lambda is equivalent to 2 pi in phase. If you have two wavelets which have the path difference of lambda, you can put that equivalent to 2 pi. That means if your path difference is d sine theta, which is the path difference for the second slit, then your phase difference would be equal to 2 pi by lambda into d sine theta. So this phase difference, that means the wavelets which are going from the second slit, they are going to lag behind. They are going to lag behind because they are going to travel the extra distance. So that is why they are going to lag behind. They are not going to lead. So the disturbances that are going to start from the second slit, you can write them in this form. Omega t minus beta minus alpha, where I'm calling alpha to be equal to 2 pi by lambda into d sine theta. You can definitely write here 2 pi by lambda into d sine theta also. That's up to you. I just put a small notation for that. So if you have done it for the second slit, the extra distance that was traveled by the wavelets originating from the second slit was d sine theta. For that, if your phase difference was alpha, if the distance becomes 2d sine theta, then your phase difference would be 2d alpha. If it becomes 3 times d sine theta, I'm repeating that if for extra distance d sine theta, you are saying that the phase difference is going to be alpha, where alpha is 2 pi by lambda into d sine theta, which we have defined here. Then if the extra distance is 2d sine theta, then the phase difference is going to be 2 times alpha. If it is 3d sine theta, it would be 3 alpha. If it is 4d sine theta, 4 alpha, and so on until you reach to the last slit, which is your nth slit. And for nth slit, this is going to be then n minus 1 times alpha. So this basically means that we have written the disturbances due to first slit. We have written disturbances due to second slit. If you want to write the disturbance for the third slit, you will write them in this form. Omega t minus beta. This phase difference for the third slit is 2 alpha. Similarly, you can do it for the fourth slit. For the fourth slit, it would be a sine beta over beta, cosine of omega t minus beta minus 3 alpha. And you can keep on doing it until you reach to the nth slit, where this would be equal to a sine beta over beta, cosine of omega t minus beta minus n minus 1 alpha, which is I have taken from here. The resultant disturbance at this point P, the point P that we are talking about here, will be a superposition of all those disturbances. क्योंकि हर एक स्लिट में से wavelets originate हो रहे हैं and they are going to reach at point P. Point P पे the resultant disturbance that you will be observing, that would be a simple superposition of the disturbances which is originating from each of the single slits. Hanji. Hello? Someone was saying something? Is my sound clear?
Yes, ma'am, sound is clear.
Okay. So at point P, then the resultant disturbance would be sum of all the disturbances. You will have E1 plus E2 plus E3, and these are the disturbances of electric field and magnetic field. Remember, we are talking about electromagnetic waves. Visible light is a form of electromagnetic waves. If you look at the expression for each one of them have a sine beta over beta common. In this expression, this one, and this one. You can take that out. So I can write it as a sine beta over beta. And let me remind that beta we defined in the single slit pattern, which was defined as this number. Lambda is the wavelength of the incident light. Pi, you know, b is the width of the slit, and theta is the angle of diffraction. So we have already defined beta. Alpha, we just defined again. Alpha is nothing but 2 pi by lambda over d sine theta. Again, everything is known. Lambda, incident wavelength, known. D, the grating element. This is also called as grating element, which is sum of your slit width and the opaque thickness. Theta is again the angle of diffraction. A sine beta or beta is common, you can take it out, and you are left with cos omega t minus beta, cos omega t minus beta minus alpha, 2 alpha, up to n minus 1 alpha. So you have something which is going to look like this. And so on. And the last term would be cos omega t minus beta minus n minus 1 alpha. If you remember, we had exactly similar trigonometric series while we were dealing with the single slit diffraction pattern. If you do not remember, go back to the single slit diffraction pattern and check it there. For this term, the summation of this term over here, all these cosine term will be given by sine n alpha by 2 by sine alpha by 2, because you have n number of terms here. You are starting from 0, right? You have 0, 1 alpha, 2 alpha, 3 alpha, 4 alpha, up to n minus 1 alpha. So you will have n here. And then you will have cos omega t minus beta minus n minus 1 alpha over 2. This is a trigonometric series whose sum is given by this expression here, from here to here. If you look at this expression, there are two terms. One which is independent of time, which basically tells you amplitude. And the second one, which is a function of time, which tells you the variation of this disturbances as a function of time. We are interested in measuring the intensity, and as I keep on saying, intensity is nothing but directly proportional to amplitude square. So you can say that your intensity is going to be a square sine square beta over beta square sine square n alpha by 2 over sine square alpha by 2. This would be your intensity. Let me remind you, again you have two terms. The first term here basically corresponds to your single slit diffraction pattern. The second expression here corresponds to interference due to n points which are separated by distance d. So your resultant intensity, as was in the case of double slit diffraction pattern, is going to be superposition of interference as well as diffraction. Your resultant intensity will be decided by both of them. Now, ideally, this is N-slit diffraction pattern. And as I said before, the value of capital N, you can take anything. We have derived the expression for single slit and double slit. If you put N is equal to 1, sine square alpha by 2 in the numerator, sine square alpha by 2 in the denominator will cancel each other out, and you will get the expression for the single slit diffraction pattern. Put N is equal to 2 here. This expression I am claiming would be equal to 4 times cos square alpha by 2. I'm going to give you approximately 30 seconds to work that out. You can say that sine alpha is 2 times sine alpha by 2 cos alpha by 2. उसका अगर आप स्क्वायर कर दोगे, so you will have 4 times cos square alpha by 2. Sin square alpha by 2 denominator और numerator में आपके पास cancel हो जाएगी. So just think about it. If your n is equal to 2. Hence, using the expression for N-slit diffraction pattern, you can go back and use it for a single slit diffraction pattern as well as double slit diffraction pattern also. And as I said before, it is universally applicable. Your number of slits, this N can be 2, it can be 20, it can be 2000, or it can be 20,000 also. It is going to be always applicable. So now this is your resultant intensity. Now we need to work out the conditions of minima and maxima as we do in every case. Here, if we talk about the condition of maxima, and these maxima are going to be called as principal maxima. The reason there are going to be secondary maxima also in this case. And we'll see why there would be secondary maxima here. If you talk about the amplitude, which was given by A sine beta over beta into sine n alpha by 2 over sine alpha by 2. Right? This was your amplitude, this term here, which I'm writing as E theta. And your intensity is basically given by A square sine square beta over beta square into sine square n alpha by 2 over sine square alpha by 2. As I said before, the diffraction term, when you talk about the maxima, it basically gives you envelope for defining the pattern. The condition of maxima is going to be decided by this term here, which is the interference term. Here, if you want this term to be maximum, the problem here is that both numerator and denominator, they are function of alpha by 2, right? So you would like to have a combination in which your numerator should be maximum and denominator should be minimum, right? आपका numerator maximum होना चाहिए, denominator जो है वो minimum होना चाहिए. If here I claim that when alpha by 2 tends to m pi, where your m would take value 0, 1, 2, and so on. What would happen in that case? Both this would become 0, right? You will have, for example, if you take m is equal to 0, in that case, your alpha by 2 is 0. So you have sine 0 upon 0. And here also you have sine 0 upon 0. If you take it pi, again, in that case also, sine pi multiplied by some number n will be always equal to 0. And your denominator is always also going to be 0. So you have 0 upon 0, which is kind of indeterminate quantity. Now there is something called as L'Hopital or Al-Hospital rule. You might be aware of this. This basically states that when you have a scenario that your limit x tends to c, your fx limit x tends to c, gx is either 0 or plus minus infinity. In that case, if you have something as this form, you can put it equal to the derivative here. Everyone is aware of this rule, right?
Yes,
we have the similar scenario here. We have our numerator 0, we have our denominator also 0. So what I can do in this case is that I can say that my E theta, which is given by this number, sine beta over beta, limit alpha by 2 tends to m pi, sine n alpha by 2 over sine alpha by 2 is going to be equal to a sine beta over beta, right? Limit alpha by 2 tends to m pi. Sine n by 2 alpha का आप differentiation करोगे, you will have n by 2 cosine of n alpha by 2. In the denominator, you will have 1 by 2 and cosine of alpha by 2. 1 by 2 से आपका 1 by 2 cancel हो गया. Now, if you plug in the value of alpha by 2 to be m pi, n is the constant, you can take it out here. Cos n alpha by 2. If alpha by 2 is m pi, this is going to be some multiple of pi. In the denominator also, you are also going to have some multiple of pi. And we know that this could be either plus or minus 1. There could be scenario in which maybe your denominator is minus 1 and numerator is plus 1 or vice versa. If you take all the permutations, combinations here, then you can have either plus 1 or minus 1 here. So if this is going to be a resultant amplitude now, we said that intensity is directly square of this term here. That means this is going to be equal to a square, n square. Plus minus wouldn't matter. अगर आप इसका square करेंगे, you will have sine square beta over beta square. ए स्क्वायर को हमने हमेशा आई नोट डिफाइन किया है, विच कोरस्पॉन्ड्स टू योर इंटेंसिटी ऑफ सेंट्रल मैक्सिमा। आपके सेंट्रल मैक्सिमा की इंटेंसिटी को जो रिप्रेजेंट करता है। सो यू हैव आई नोट एन स्क्वायर sin square beta over beta square. This is going to be your intensity of maximum. Look at the expression here. Intensity of maxima, principal maxima rather here, is directly proportional to n square. That means more are the number of slits, higher will be the intensity of principal maxima. And I'll show you a figure and I'll remind you to look at and to verify this expression again at that time. This basically means that if you have 4 slits and if you have 400 slits, then the intensity of principal maxima is going to be much larger in the 400 or 4000 slit as compared to 4 slits. And this principle is used in your diffraction grating, where you have approximately 15,000 lines per inch. That this basically means that in almost 2.54 centimeter, you will have 15,000 lines. So this means you have 15,000 slits in 2.54 centimeter. So this is the expression for intensity. Now let's talk about the location of this principal maxima. These principal maximas are when your alpha by 2 is more or less equal to m pi. So that means if I'm saying that alpha by 2 is equal to m pi, where your m can have value 0, 1, 2 and so on. We defined beta as pi over lambda b sine theta, alpha as 2 pi by lambda into d sine theta. That means 1 by 2 into 2 pi by lambda d sine theta is equal to m pi, or which would mean that 2 से 2 cancel हो गया, आपका pi से pi cancel हो गया, d sine theta is equal to m lambda, where m is equal to 0, 1, 2. This would be your condition for principal maxima. जब कभी भी ये वाली condition satisfied हो जाएगी, you will have at those particular value of theta principal maxima. And this is also called as grating equation. I'll ask you to recall this equation when we are going to talk about the diffraction grating. So this was all about maxima. Now what about the minima? Let's talk about minima. Your expression for intensity is given by this. And these are your beta and alpha again. For minima, that means we would like your intensity to be 0. As was in the case of double slit diffraction pattern, here also, even either you can have this term 0, then also your intensity would be 0, or you can have this term 0, even then your intensity would be equal to 0. So that means either your sine beta is equal to 0, but your beta cannot be 0. क्योंकि अगर आपका बीटा भी 0 हो गया तो अगेन यू हैव 0/0, एंड वो वाली कंडीशन हम ऑलरेडी सिंगल स्लिट में डिस्कस कर चुके हैं कि वो आपका सेंट्रल मैक्सिमा को कोरस्पॉन्ड करता है. क्योंकि अगर आपका बीटा 0 हो गया, दैट वुड मीन आपका ना तो स्लिट विड्थ 0 हो सकती है, ना लैम्डा 0 हो सकता है, योर थीटा इज बेसिकली इक्वल टू 0. और वो अगर आपका थीटा 0 है तो वो आपका सेंट्रल मैक्सिमा को कोरस्पॉन्ड करता है बेसिकली. If your sine beta is equal to 0, that means beta is equal to n pi, where n can take value from 1 onwards. n जो है वो 0 नहीं हो सकता, क्योंकि n अगर 0 हो गया तो आपका बीटा 0 हो गया, जो हम एक्सक्लूड करने की बात कर रहे हैं. इफ योर बीटा इज इक्वल टू एन पाई, बीटा की वैल्यू यहाँ पे प्लग इन कर दीजिए, पाई ओवर लैम्डा बी साइन थीटा, सॉरी बी साइन थीटा इज इक्वल टू एन पाई। पाई से आपका पाई कैंसिल हो गया, विच मीन्स दैट बी साइन थीटा is equal to n lambda, n is equal to 1 2 3 and so on। जिस किसी भी पर्टिकुलर वैल्यू ऑफ थीटा पे ये वाली कंडीशन सेटिस्फाई हो जाएगी, वहां पे आपकी इंटेंसिटी 0 हो जाएगी। और this was the one condition, or the second condition would be if your sin n alpha by 2 is equal to 0 but your sin alpha by 2 should not be 0। क्योंकि अगर ये भी 0 हो गया और ये भी 0 हो गया, वो वाली जो कंडीशन है वो आप ऑलरेडी प्रिंसिपल मैक्सिमा में डिस्कस कर चुके हैं। ये दोनों 0 तब होंगी जब आपका अल्फा बाई 2 है वो एम पाई के इक्वल होगा। वो वाली कंडीशन है वो हमने प्रिंसिपल मैक्सिमा में ऑलरेडी डिस्कस कर ली। सो नाउ यू वुड लाइक ओनली योर डिनोमिनेटर टू बी 0, sorry, you would like only your numerator to be 0 but your denominator should not be 0 simultaneously, which would mean that your n alpha by 2 is equal to, I have already used m and small n, so let's call this as p pi, and your p cannot be equal to 0, it cannot be equal to n, it cannot be equal to 2n 3n and so on। क्योंकि अगर आपका p 0 हो गया यहाँ पे तो आपका अल्फा बाई 2 भी 0 हो जाएगा, और अगर आपका p n के इक्वल हो गया यहाँ पे, दैट मीन्स योर अल्फा बाई 2 इज इक्वल टू पाई। अल्फा बाई 2 इज इक्वल टू पाई की जो कंडीशन है वो आप ऑलरेडी यहाँ पे ले चुके हैं प्रिंसिपल मैक्सिमा में। p अगर आपका 2n के इक्वल हो गया, दैट वुड मीन अल्फा बाई 2 इज इक्वल टू 2 पाई, वो वाली कंडीशन भी आप यहाँ पे यूज कर चुके हैं प्रिंसिपल मैक्सिमा में। And this is the reason your p cannot be equal to 0 and 2n 3n and so on। क्योंकि जब कभी भी p 0 and 2n 3n 4n होगा, वो वाली कंडीशन आपके प्रिंसिपल मैक्सिमा को कोरस्पॉन्ड करेगी। That would mean that from here that your alpha by 2 is basically p over n into pi, and p cannot be equal to 0 and 2n 3n। I'm going to stop saying that। अल्फा बाई 2 की अगर आप यहाँ पे वैल्यू प्लग इन कर देते हैं, अल्फा इज 2 पाई बाई लैम्डा इंटू डी साइन थीटा इज इक्वल टू पी ओवर एन 2 पाई। 2 से 2 कैंसिल हो गया, यहां से पाई कैंसिल हो गया, विच बेसिकली मीन्स दैट योर डी साइन थीटा इज इक्वल टू पी ओवर एन लैम्डा, where your p cannot be equal to 0 and 2n 3n and so। इसका क्या मतलब हुआ कि आपकी मिनिमम इंटेंसिटी होगी जब कभी भी योर डी साइन थीटा इज इक्वल टू p की वैल्यू 0 नहीं हो सकती, p की नेक्स्ट वैल्यू होगी 1 लैम्डा ओवर n, नेक्स्ट वैल्यू 2 टाइम्स लैम्डा ओवर n, 3 टाइम्स लैम्डा ओवर n सो ऑन। कब तक जाते जाएंगे n माइनस 1 लैम्डा ओवर n। n अलाउड नहीं है तो नेक्स्ट जो आपका होगा दैट वुड बी n प्लस 1 लैम्डा ओवर n एंड सो ऑन। आप कैन कीप ऑन गोइंग, फाइनली यू विल रीच 2n माइनस 1 लैम्डा ओवर n। 2n लैम्डा ओवर n अलाउड नहीं होगा क्योंकि आपका p है वो 2n के इक्वल नहीं हो सकता है, सो इसके बाद में आपके पास नेक्स्ट वाली टर्म आएगी, वो आएगी 2n प्लस 1 लैम्डा ओवर n। यहाँ पे ये जो मिसिंग टर्म है ये वाली है, यहाँ पे ये वाली जो टर्म है, लेट मी चेंज द कलर, यहाँ पे और यहाँ पे एंड यहाँ पे, दीज आर द कंडीशंस ऑफ योर प्रिंसिपल मैक्सिमा जो हम ऑलरेडी डिस्कस कर चुके हैं। Because you are saying at this point d sin theta is equal to 0 which would be satisfied here। यहाँ पे आप कह रहे हैं d sin theta is equal to 1 लैम्डा, क्योंकि यहाँ पे n लैम्डा ओवर n हो गया तो n से n कैंसिल हो गया, d sin theta is equal to 1 लैम्डा, वो वाली कंडीशन भी आप यहाँ प्रिंसिपल मैक्सिमा में इंक्लूड कर चुके हैं। यहाँ पे 2n-1 से हमने 2n+1 पे जंप किया, जो मिस किया है दैट इज 2n लैम्डा ओवर n, n से n कैंसिल हो गया, यहाँ पे आपके पास 2 लैम्डा बन गया, d sin थीटा इज इक्वल टू 2 लैम्डा, वो भी आपके प्रिंसिपल मैक्सिमा में कवर हो गई है। सो यू हैव प्रिंसिपल मैक्सिमास एट दिस पॉइंट्स। और फिर यहाँ पे आपके क्या होंगे, जहां कहीं भी ये वाली कंडीशन सेटिस्फाई होंगी वहां पे आपके पास में मिनिमा मिलने स्टार्ट हो जाएंगे। नाउ यू आर सेइंग कि आपके पास में एक मिनिमा यहाँ है, एक मिनिमा यहाँ है, दो मिनिमा तभी डिफाइन करेंगे जब उनके बीच में एक मैक्सिमा आएगा, राइट? वरना तो मिनिमा का मतलब क्या होगा, तभी आप मिनिमा डिफाइन कर सकते हो ना। ऐसा तो है नहीं कि कंटिन्यूअसली डार्क 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 रहेगा, तब तो आप इंटेंसिटी में कोई वेरिएशन ही नहीं है। अगर आप कह रहे हो कि आपके पास एक मिनिमा इस लोकेशन पे है और एक मिनिमा इस लोकेशन पे है फॉर एग्जांपल, सो दैट मींस यहाँ कहीं पे आपकी इंटेंसिटी जो है वो हाई होनी ही चाहिए। दैट वुड बेसिकली मीन दैट इन दो मिनिमा के बीच में जो आपने फॉर एग्जांपल लैम्डा ओवर n और 2 लैम्डा ओवर n के बीच में किया है, यहाँ पे कहीं ना कहीं यू शुड हैव अ मैक्सिमा एंड दोज मैक्सिमास आर कॉल्ड एज सेकेंडरी मैक्सिमा। उनको सेकेंडरी मैक्सिमा बोला जाता है। I would also like you to remember with respect to maxima, अगर आप मैक्सिमम में, प्रिंसिपल मैक्सिमम में लैम्डा बाई एन अगर ऐड कर देते हो, लुक एट हियर, यहाँ पे प्रिंसिपल मैक्सिमा की लोकेशन है, उसमें लैम्डा बाई एन अगर आप ऐड कर दोगे तो आपके पास में मिनिमम की कंडीशन मिल जाएगी। फॉर एग्जाम्पल यहाँ पे यू हैव डी साइन थीटा एट दिस पर्टिकुलर पॉइंट, यू हैव डी साइन थीटा इज इक्वल टू लैम्डा, और अगर आप उसमें लैम्डा ओवर n ऐड कर देते हो तो आपको नेक्स्ट मिनिमा मिल जाएगा, जो कि यहाँ पे इस एक्सप्रेशन में दिया गया है। सो प्रिंसिपल मैक्सिमा में लैम्डा ओवर n अगर आप ऐड कर दोगे तो आपको वहां पे मिनिमा मिल जाएगा। I want you to remember this because I am going to use this while talking about the resolving power of a diffraction grating, where I am going to say principal maxima की अगर ये लोकेशन है उसमें अगर आप लैम्डा ओवर n ऐड कर दोगे तो आपको वहां पे मिनिमा मिल जाएगा। So these are your conditions of minima, either this is satisfied or this is or satisfied, आपकी intensity automatically उन points पे zero हो जाएगी। As was in the case of double slit diffraction pattern, here also there is something called as missing order, and this is the last thing that we are going to discuss today. I need to make some announcements. Missing orders happen when यहाँ से ये वाली condition जो है, this is saying you should have a maxima. अगर ये वाली condition true है तो simultaneously ये वाली तो हो नहीं सकती, क्योंकि या तो आपका d sin थीटा इंटीग्रल ऑफ लैम्डा होगा या वो कोई ओड मल्टीपल ऑफ लैम्डा बाई 2 होगा या इवन मल्टीपल होगा, दोनों साइमल्टेनियसली नहीं हो सकती है। तो कभी भी ये वाली कंडीशन और ये वाली तो साइमल्टेनियसली सेटिस्फाई हो नहीं सकती है। बट देयर आर सिनेरियोज वेयर योर दिस इक्वेशन and this equation can be simultaneously satisfied. This basically means that you have the interference maxima which basically says that d sin theta is equal to m lambda, where your m can have 0, 1, 2 and so on, but you have the diffraction minima also at the similar value of theta. b sin theta is equal to n lambda, where your n can take 1, 2, 3 and so on, which is this condition here. If at certain value of theta ये दोनों कंडीशन अगर साइमल्टेनियसली सेटिस्फाइड हैं, if this equation and this equation, those are called as missing order. That means इंटरफेरेंस के वो वाले जो m की वैल्यूज हैं वो मिस हो जाएंगे आपके इंटेंसिटी डिस्ट्रीब्यूशन पैटर्न से. These are the concept of missing order. Let me show the picture for the same, where I'll show you at the top, sine square n alpha by 2 over sine square alpha by 2 is shown as a function of alpha by 2 for 5 number of slits, and then it is shown for the 12 number of slits. As I said, there are going to be n minus 1 minima. अगर आपके मिनिमा n minus 1 होंगे तो आपके n minus 2 सेकेंडरी मैक्सिमा होंगे. 5 स्लिट्स के लिए आप देखो, ये आपका एक प्रिंसिपल मैक्सिमा है, ये आपका सेकंड प्रिंसिपल मैक्सिमा है. इन दोनों के बीच में यू हैव 1 मिनिमा, you have 2 minima, you have 3 minima, you have 4 minima. So 5 minus 1, 4 minima. अगर आप सेकेंडरी मैक्सिमा की बात करो 1, 2 and 3. 5 minus 2 basically is equal to 3 secondary maxima. अगर आप 12 slits की बात करते हो, 12 slits में you will have 11 minimas here. ये आपका एक प्रिंसिपल मैक्सिमा है, ये आपका सेकंड प्रिंसिपल मैक्सिमा है. इन दोनों के बीच में you will have 11 minimas and you will have 10 secondary maxima, which are given by here. Another thing that I asked you to notice that your intensity is directly proportional to n square number of slits in the your principal maxima. यहाँ पे इसकी width देखिए और इसकी width देखिए. The width of this is much less as compared to width of this. So as you keep on increasing the number of slits, and here you have just moved from 5 to 12 slits, आपके प्रिंसिपल मैक्सिमा की इंटेंसिटी जो है वो कहीं ज्यादा इंक्रीज हो जाएगी, और वो जो पीक्स हैं आपके प्रिंसिपल मैक्सिमा की वो कहीं ज्यादा शार्प हो जाएंगी. इमेजिन मेकिंग दीज n to be equal to I don't know 10,000 or 12,000 or 15,000. एंड अगर आपकी इंटेंसिटी यहाँ पे जा रही है क्योंकि आपकी एनर्जी कंजर्व्ड है, सो दैट मीन्स यहाँ से इंटेंसिटी गायब हो रही है, और वो इंटेंसिटी आपकी यहाँ पे पंप की जा रही है क्योंकि आपकी एनर्जी तो कंजर्व्ड ही है ना. सो दिस इज ऑल अबाउट द N-slit diffraction pattern. Anyone has any doubt in this? No. Okay, so I'm going to show you the LMS now. I would like you to notice a couple of things here because the quiz announcement has been uploaded here, which is announcement, links and instructions for quiz 1. इस पेज को प्लीज कीप इट डाउनलोड बिफोर हैंड. लास्ट मिनट में लॉग इन करके यहाँ पे अलग अलग ग्रुप्स के लिए अलग अलग लिंक प्रोवाइड किए गए हैं गूगल के क्विज के लिए. अगर लास्ट मिनट पे आप सभी लोग इसमें लॉग इन करेंगे, कैन यू सी माय स्क्रीन?
यस मैम.
ओके, अगर लास्ट मिनट पे एलएमएस पे लॉग इन करके इसको डाउनलोड करने की कोशिश करेंगे, एलएमएस माइट क्रैश इन दैट केस और आप एक्सेस नहीं कर पाएंगे. सो इट्स अ रिक्वेस्ट, आप प्लीज इस पेज को बिफोर हैंड डाउनलोड कीजिए. एज आई सेड यस्टरडे, कीप योर आई कार्ड्स हैंडी इफ यू डू नॉट रिमेंबर योर रोल नंबर्स. क्विज का जो टाइम है इट सेज 7:11 शार्पली आपका क्विज क्लोज हो जाएगा. सो मेक श्योर यू क्लिक द सबमिट बटन बिफोर 7:11. अगर उसके बाद अगर आप सबमिट करते हो तो वो आपका क्विज एक्सेप्ट नहीं करेगा और आपके जो मार्क्स हैं वो बाय डिफॉल्ट ऑटोमेटिकली 0 वहां पे पुट कर देगा. सो प्लीज मेक श्योर बिफोर 7:11 यू क्लिक ऑन द सबमिट बटन. एंड द लास्ट थिंग, अपने पर्सनल जीमेल अकाउंट से लॉगिन करके मेक श्योर जहां कहीं से भी आप क्विज अटेम्प्ट कर रहे हैं, चाहे इंटरनेट एक्सप्लोरर है या क्रोम है, व्हाटएवर ब्राउजर यू आर यूजिंग, उसमें आप अपने थापर के जीमेल अकाउंट से लॉगिन कर लीजिएगा. अदरवाइज यू वोंट बी एबल टू एक्सेस द क्विज. लास्ट टाइम देयर वर लॉट ऑफ स्टूडेंट्स जिन्होंने लॉग आउट नहीं किया था एंड एट द लास्ट मिनट दे वर नॉट एबल टू एक्सेस द क्विज. सो प्लीज डू नॉट मेक द सेम मिस्टेक अगेन in the last semester, I mean to say. This is all I have to say about the quiz. Anyone has any doubt related to quiz also? No, I'll end it then. There will be no numericals in the quiz. All the questions are going to be MCQ.
Ma'am, there will be no MSTs this time.
I do not have any information about that.
Okay, ma'am.
Yes.